Oh, one thing I didn't say is just a reminder with 5.1 that we did last week. Don't forget that there are problems from page 260 in the book. And it's kind of the digital version of the book is a little bit loose with page numbers. You know, if you go to page 260, it might be the second page of the assignments, or it might be the first or the page before the assignments. Make sure that you're willing to scroll around a little bit in there to find where those assignments are. It's something I noticed. I, I, uh, I have a hard copy of the book that I use most of the time, and I figured, you know what, I should see what they're looking at. And I went in and I took a look at uh, the electronic version, and I noticed that it doesn't always land exactly on those pages, but it wasn't off either. So, you know, I'll just leave those page numbers as they are. Make sure you're finding the exercises for 5.1 in the neighborhood of page 260, and then after today, it's in the 7.1 of the neighborhood of 352. Oh, sure thing, Shelby. Absolutely. That's a really good question, actually. What we'll do, Shelby, is we'll go ahead and go through the new material first. I'll talk about the new material from 7.1, and that way, if students don't have any questions, they can be done for today. If they want to stick around and see what those questions are, and we want to talk about them, that's absolutely fine. But that way, we'll put questions from previous stuff on the back end rather than on the front end, so that if somebody's really comfortable with what we did last week, that they can be done for today. I will say that there are days where we're going to have a relatively long instructional part of class. Sometimes we might fill up the entire time. Today is not one of those days. This is a relatively short introduction to the types of graphs, so we'll have lots of time for homework on the back end. Great question, Shelby. That was perfect, and gave me a chance to talk about something that here's how we'll do that when it comes up is perfect. So I appreciate you bringing that to my attention. All right, let's talk types of graphs. The first type of graph we're going to look at is something you're probably pretty familiar with. It's a bar graph. A bar graph is used to show data that's in specific categories, and it shows raw data. Not always, but often. We're going to have a horizontal axis down here. The x-axis is where our categories would go. Whatever those categories might be, they go across the x-axis. And then over here, we would have the y-axis, and those would show us the frequency. How many data points are there within each one of these categories? And then we would have bars that go along with those categories, and the taller the bar, the more data points there are within a certain category. I understand that you're probably very comfortable with bar graphs, but I just want to kind of remind you, this is what we would call a vertical bar graph because the bars go in a vertical direction. You could also have a horizontal bar graph. There's nothing wrong with that. I think they're less impactful. So for us, we're going to talk about the vertical bar graphs, where our categories are on the x-axis and our frequencies are on the y-axis. One thing that's really important to note about bar graphs, something that is a feature of bar graphs, is they actually show us the raw data. Not every graph we look at today is going to do that. And so this is sort of a unique feature of bar graphs that's a really important distinguishing characteristic. This is, hey, what's so good about a bar graph anyway? Well, one of the things good about a bar graph is you can actually see the raw data. If you have any questions about anything we're talking about as we do it, please don't hesitate to ask. Here's an example of a bar graph. A class of students has the following eye color data. 16 students have brown eyes, 6 students have blue eyes, and 2 students have green eyes. And we can see right over here is our bar graph. Our x-axis, our horizontal axis, that's where our categories are. Green, brown, and blue. And then over here on the y-axis, we have our frequencies. How many are in each category? And again, the key to the bar graph is that we can actually see the raw data. What I mean by that is we can look at this bar right here and see that there are 16 students. Well, not if I write it in that color. We can actually see that there are 16 students with brown eyes. Similarly, we can see that, well, there's not a marker over there, but it's halfway between 0 and 4. So there are 2 students that have green eyes. And similarly, it's halfway between 8 and 4. There are 6 students with blue eyes. We can see the raw data right there in the graph. So not only can we see brown has the most, green has the least, but we can also see the raw data right there in the graph. Also, something I want to point out about bar graphs is they make sense in any order. We could pick those categories up and move them around. And what I mean by that is, if I were to take the green bar and put it over here, some of you who may be a little bit, I'm not sure what word I would use to describe it, particular. How's that? I tend to be one of those particular people. When I look at this graph, I'm like, why in the world wouldn't you put it from highest to lowest? You know, that's just kind of how I'm wired. And well, you can. You could pick up that green one, put it over here on the right, get rid of this one altogether, use this as your bar graph. Now you're looking at highest to lowest if you prefer that, if you need that. But it shows the exact same thing. We have the same categories, we have the same data, but we can rearrange them however we want to present the data in a certain way. And like I said, a lot of what we talk about today is probably going to be familiar and comfortable for you. So I don't anticipate a ton of questions, but if there's anything that pops in your head, don't be shy about asking. A special type of bar graph is known as a histogram. So you can see from looking over here that, you know, we definitely have a bar graph. This is a special type of bar graph. It has some rules that go with it. And this one over here, it doesn't have to be, but it could be batteries were tested and we wanted to see how many hours they live. And so we have 37, 38, 39, 40, 41, 42. That's how many hours the batteries live. And while those don't feel like categories the same way that green, blue, and brown do, those are categories. How many batteries fell in the 37? How many batteries fell in the 38? And so on. What makes this a histogram? The particular rules that go with histograms are the following. Our categories that are on the x-axis represent continuous data. If you look, green, blue, and brown, we can put in any order. But the data we have here, 37, 38, 39, 40, 41, 42, we wouldn't want to rearrange those. There's a certain order to them based on the kind of data that it is. This is continuous data. It goes 37, 38, 39, 40. There's an order to it. We're going to keep that order when we make our histogram. We're not going to mess with that. And you can also notice that these bars, when they're drawn, there's absolutely no gaps between them. They're pressed right up against each other. These bars are presented without any gaps. And that's going to be the case in a histogram. I do want to say, it's possible that you'll see a histogram sometime that, you know, let's say there's 43 right here and 44 over here, and let's say the picture looked like, I gotta squeeze it in where I can write it. There it is. The picture looked like that. Your first thought might be, wait a minute, you said that a histogram's done without any gaps, and when I look at this picture, I see a gap. Well, if you know for sure it's a histogram, then that tells you that these things are true. We have continuous data on the x-axis. There's no gaps. Anybody got an idea of what might be happening here? Why we'd have a little blank spot? If you don't, it's okay, but I figured I'd give you a shot, keep you a little bit engaged, because I know. Excellent, Denise. You're exactly right. And Summer was probably right there behind you. And Summer, it's okay if you were to type it, because a different way to phrase that might be good. But yeah, Denise is exactly right. you know what? There is a bar here. It just has no height to it. It's a zero. Perfect, Denise. You nailed it. So yeah. So even if you were to see something that looks like a gap, if you know it's a histogram, it just means there's no height to the bar that's in that spot. It's a zero. Perfect. This is a special type of bar graph that has these particular rules that go with it. Honestly, in this part of the course, histograms are not going to be that important for us. We're going to revisit them again in section 7.3, and that's when they'll be more significant. What the good news is, when we get there and I'd say it's a histogram, you'll know exactly what I'm talking about. Line graphs. Well, a line graph is exactly what it sounds like. It makes a line. Now, I guess technically it's a series of line segments, but we can be a little bit looser than that and go ahead and say, because we have lines, we have a line graph. And a line graph, the thing about a line graph that it's really useful for is change over time. That's where a line graph really has its value. This is the power of a line graph. Here we have funds spent on road construction in a certain town in 2010, 11, 12, 13, and we can see here's how much they spent in 2010, here's how much they spent in 2011, 2012, and 2013. And then essentially to make this line graph, we just connect the dots. And so we draw in our lines to make a line graph. The reason that a line graph is so great for change over time is because of the way we read it. When we go up like this, oh, wait a minute, up, that has to do with something. There's a math word that goes with that, and that math word is the slope. It's because this line graph has slope, that's where the value comes from. Now, we're not going to do the find the slope of a line using the formula, y2 minus y1 over x2 minus x1. We're not going to do that. If you happen to remember that from an algebra class, that's awesome. But basically, slope, what we're going to be concerned with here is if it goes up, we would say it's increasing. And if it goes down, it's decreasing. And so when the slope goes up, and just a quick visual inspection here, we can see, oh yeah, the amount of money they spent on road construction went up. It was increasing in those years. And over here, the amount of road construction money went down. It was decreasing over here. And that's what the slope's going to tell us, increasing or decreasing. And when I say going up and going down, I mean reading from left to right. When we read a line graph, we're going to read it the same way we would read a book, left to right. So it goes up from left to right, it goes down from left to right. That's increasing and decreasing. I haven't mentioned that little piece in the middle just yet. Would you say this is increasing or decreasing? What do you think? And if I get 12 people typing, it's totally fine with me. Awesome. We're Sandy, Katie, Shelly, Jaylee, you're all exactly right. This is an increase. And what we would say here is this increase, because you can see how from 2011 to 2012, that's a steeper increase. It went up more than it did from 2010 to 2011. We could say, that it's increasing more, or it's increasing faster, or something along those lines, to say that, if the question were, where was the increase more significant? We would say, well, the increase was more significant here from 2011 to 2012. A really nice question for this would be maybe a matching or a multiple choice type question that says, there are two places in this picture where the spending on road construction was increasing. Over which years did it increase more? And then the 2011 to 2012 would be the answer. Any questions on this? I promise I won't try to trick you. I'll try to be as clear as possible. But I want you to understand that We have increasing and we have decreasing. And there'll be times when we have like two different places where it's increasing. So where did it increase more is a great question. And that would be in this window here. Let me know if you have any questions on any of that. Oh, and please don't forget this sort of highlight about line graphs. They're great for change over time because our eyes have a really good ability to see it went up again, it went down. All right. Pie charts, also known as circle graphs. You might see either terminology for these. I tend to say pie charts. I think our book tends to use circle graphs. They're both equally good. Whichever one you like better is totally fine. What a pie chart is good for is comparing different categories, kind of like we did with the bar graph. But instead of showing raw data, what a pie chart does is it shows relative proportions and percentages. Just like bar graphs and line graphs, I imagine you're pretty familiar with a pie chart where you've got a circle and it's chopped up into different pieces to show different proportions. And, we might have whatever the particular categories are, we've got them shaded in certain places. And what this does for us is I can't see any raw data in here, but what I can see at a relatively quick glance is blue's the most, yellow's the least. And I can kind of see that, red looks like about twice as big as yellow, and green and red look to be about the same. Those are the kind of things we can see at a quick glance on a pie chart. When we go to make a pie chart, which is what we're going to do next, one of the things that's going to be important for us is thinking about, okay, how am I going to divide up this circle so that the proportions, a nice word from last week, are correct? I want this to be proportional to whatever my data is, and I need to divide up this circle in a certain way. Something that's going to be really important for us for that. If you remember this, great. If not, it's okay. If I go all the way around a circle, how many degrees is that? Anybody remember? All the way around the circle, how many degrees would that be? Awesome. Very good. Sunshine, Jalen, Katie, Summer, terrific. You're exactly right. That'll be 360 degrees. Keep that in mind. The next thing we're going to do is make a pie chart. And the idea that the entire circle has 360 degrees. Oh, good, Nadine, I caught yours too, is going to be important for us. All right. So we're going to use that eye color data that we had from before. We have brown eyes. We have, we have blue eyes. And finally, we have green eyes. And the number of students that had each of those color eyes. Well, let's see, brown were 16 students. Blue was 6 students. And green were 2 students. And what we want to do is, we saw what a bar graph would look like. Now we're going to make a pie chart out of that data. And what we're going to do is we are going to take these 360 degrees that are in that circle, and we're going to divide those among these 3 categories. Now, we don't want to just say, well, you have 3 categories, so it's brown and blue and green, because that doesn't represent the data at all. They're not all equal, so we want to make sure that each one of these categories gets the number of degrees that it should have proportionally based on this data set. And so a number that's going to be really important for us, we know the total of number of degrees around a circle. So we're going to want to know the total number of data points that we have, the total number of students. Let's see, 16 plus 6 plus 2 would be 24. So there's a total of 24 students, and there's a total of 360 degrees. With that in mind, the way we're going to go about figuring out how many degrees should I give to Brown is we're going to use a proportion. We want to divide these proportionally, so I'm going to use a proportion. And here's that proportion. And if you're not sure where these numbers came from or why I did it this way, make sure you ask. But 16 out of the 24 students have brown eyes. So how many out of the 360 degrees should go to brown? That's our proportion that we're setting up here. And it's great proportion practice from last week. Last week leads beautifully into pie charts. I have 16 brown out of the total. How many degrees then out of the total? That's the philosophy we're using to set up this proportion. Some of you may prefer to do this with percentages. And while that works a lot of the time, the downside to using percentages instead of a proportion is if you have to round. If you use percentages and you get a decimal and then you round that decimal, you may be off by a degree or two because of the rounding. It doesn't mean what you've done is invalid or completely wrong. You just have to realize if you're going to do it with percentages and decimals, don't do any rounding until you get to the very end. With proportions, we don't have to worry about that. We'll go ahead and solve this thing just the way we did last week. We'll cross multiply and have 24 times x is 16 times 360. 5,760. If you see something you're unsure of, you let me know. From here, we'll divide both sides by 24. Those will cancel, leaving just the x. And what I end up with is x is whatever 5760 divided by 24 is 240. So how many degrees am I going to give to Brown? I'm going to give 240 degrees to Brown. How are we going to do that in this pie chart over here? Well, we'll start out with a line right there at the top, which is 0. It's also 360. Those are in the same place. And what I need to do is I need to go around 240 degrees to draw a line in for Brown. I don't have a protractor. I'm not going to ask you to use a protractor. If it's 360 degrees all the way around, how many degrees is it halfway? Perfect, Summer. 180. And what about halfway to that 180? What would the degrees be over there? Yeah, yep, 90. And then just to sort of give us a nice little scale here, what's going to go over there? It's 180 plus another 90 to get there. Yeah, Summer is dialed in. Very good. That's going to be 270 over there. And so essentially what I've got here is, this is where 90 would be, this is where 180 would be, this is where 270 would be, and then when I make it all the way around, that's where 360 would be. We don't have to be perfect here. If I want to go around to wherever 240 would be, that's going to be, let's see, somewhere about right there. And if I label it 240, that's just fine. Doesn't have to be perfect, but this is the 240 degrees that I am giving to brown eyes. So, all right, there we go. We've made that part of our pie chart. I still need to figure out how many degrees am I going to give to blue? How many degrees am I going to give to green? Well, I'll just go right down the list and we'll do blue next. And I'm just going to set up a proportion the same way. Now it's 6 students out of 24 total equal how many degrees out of 360 total? I'll go through this process. You let me know if anything doesn't make sense. We'll cross multiply and have 24x equals 6 times 360. 2,160. Divide both sides by 24, and x is 90. So how many degrees am I going to give to blue? I need to give 90 degrees to blue. Now there's two ways you can do this, and either way is just fine. Um, One way that you might see right away is, well, 90 degrees, couldn't I just draw that right here? Make this blue, and there's my 90 degrees for blue? Absolutely yes. There's nothing wrong with that at all. But if you wanted to go biggest to smallest, if you wanted to do the brown, then the blue, then the green, what you don't want to do is try to draw a line here at 90 because you can't give these degrees to blue. They've already been given away. Brown already has those. Blue can't have them because brown already does. What we would need to do then is start here at 240 and go 90 from there. So we start at 240 and we go 90 degrees from there. So if I was at 240 and I go forward 90 degrees, that'll put me at 330 degrees. And that's where my next line needs to get drawn then. Here at 330 degrees. And now I've got from 240 to 330, that's 90 degrees. That's the number of degrees I wanted to give to blue. So now I can give these to blue. Let me know if you have questions about anything I just did there um, to give those to blue. The key thing is we can't give these 90 degrees to blue because those already belong to brown. Those have already been given away. So we've got to find 90 unclaimed degrees to give to blue. Finally, you might say, well, then clearly the rest is going to be green, and you'd be exactly right. Just to make sure though, from 330 to 360 would be 30 degrees. I'm going to go ahead and set up my proportion just to make sure of it. And so now it's going to be 2 out of 24 students. So how many out of 360 degrees? Again, good proportion practice. 24x is 2 times 360, 720. Divide both sides by 24. X is 30. We're given 30 degrees to green, and sure enough, that's what we did. And so we found out how many degrees should go to brown, to blue, and to green, and then we put those in our pie chart. Are there any questions on anything that we did there to make that pie chart? One question you might have, even though you don't know you have it, is, well, how are you going to ask us to draw a pie chart? Because we can't draw a pie chart for you. You know, you're exactly right. I have a couple of ways I can go here. One way is to give you a couple of different pie charts and have you tell me which one's correct for a certain data set. And there's another way to go that I really like for pie chart questions, and it's like this. Let's say we were collecting data on people's favorite meals, and 6 said breakfast, 10 said lunch, and 14 said dinner. And you're going to make a pie chart for this data. My question to you, which is a great way for me to ask these types of questions, is what number of degrees should be given to dinner? I'm going to set up a poll for this to give you a chance to try it. But notice, all I'm asking, I'm not asking you to draw the pie chart, although we're going to do that together. All I'm asking is how many degrees should be given to dinner? I'll set up a poll for this and give you a chance to try it. Like always, if you come up with an answer that's not one of those, pick the one that's closest to yours. That way I'll know you've had enough time to try it. This is definitely the kind of question you could expect to see in a quiz, in a homework, on an exam. Let's go another 20 seconds on this and then talk about it. If you need more time, it's okay to let me know. All right, let's see how this one went. Okay, not unanimous, but definitely strong agreement. That's good news. Okay, so uh, let's go ahead and take a walk through this one. So the data I've been given here is that there is breakfast, which 6 people prefer, lunch, with 10 people prefer, and dinner, which 14 people prefer. Keeping in mind that what I'm doing here is making a pie chart, I've got a circle that has 360 degrees in it that I need to divide up amongst breakfast, lunch, and dinner in a way that's proportional to this data. And I say that word on purpose because I want to sort of steer you towards that proportion approach to answering this question. Now, if we were going to go through the whole process of making a pie chart, which we're going to do, we would need the total. And let's see, 14 plus 10 would be 24 and 6. So there are 30 total people. So 30 total people, 360 total degrees, and that's how we're going to set up our proportions to divide this thing out. So to begin with, we'll have breakfast. And so 6 out of the 30 people that were surveyed chose breakfast as their favorite. So based on that, how many out of 360 degrees should be given to breakfast? We'll cross multiply here and have 30x equals 6 times 360 is 2,160. We'll divide both sides by 30 and get 72 degrees. So 72 degrees are going to be given to breakfast. Boy, 72. How am I going to draw 72? I mean, okay, 180's down here and 90's over here and 270's over here. How in the world am I going to draw 72? And I've seen really cool paper for elementary school use where it takes the 360 degrees and divides it up into, you know, 360 little pieces, which would be perfect for having students make a pie chart. But for us, if we're in the ballpark, it's okay. So we draw a line over here, we label it 72, that's just fine, and we'll call that breakfast. That's the part of my pie chart that's given to breakfast. And then, okay, well, we need lunch. Lunch has 10 people in it, so 10 out of the 30 people said lunch was their favorite. So how many out of the 360 degrees should we give to lunch? We'll cross multiply. 30x is 10 times 360. That's 3,600. Divided by 30. 120 degrees are going to be given to lunch. So 120 to lunch. I'm not going to just draw a line here at 120 and call all this lunch because that's already been given away. That's already been given to Brown. I can't do that again. So I'll start here at 72 and I'll go 120 from there. I'm not sure where that's going to land me, but 72 plus 120, So 192. Again, kind of a clumsy number to put on our pie chart, but we'll go down here where 192 would be. And then we're going to give that part of our pie chart to lunch. All right, well then by default, the remaining part over here has to be dinner, and that's true. But we had a question we wanted to answer. What number of degrees should be given to dinner? All right, well, 14 out of 30 people chose dinner. So how many out of the 360 degrees should be given to dinner? And we cross multiply, and we get 30x is equal to whatever 14 times 360 is, 5,040. And then we'll divide both sides by 30, and x is 168. So 168 degrees are going to be given to dinner. Just to make sure, we start at 192. If I were at 192 and I added 168 to that, sure enough, that lands at 360, so I feel really good about my answer. And so, sometimes it can get lost in all of that, but what we were doing here was, what number of degrees should be given to dinner? Our answer to that question was 168. We went through the whole process of making the pie chart, chopping up all 360 degrees to give to breakfast, lunch, and dinner. Honestly, if this were a question that you saw on a quiz or an exam, you don't have to go through that whole process. Really, all you need to do is right here and say, well, if 14 out of 30 people chose dinner, how many degrees out of 360 would that be? I just need to solve that proportion. 168 is the answer, and we don't have to go through the whole process of drawing the pie chart. My philosophy there is, if you can figure out how many degrees should be given to dinner, then I'm confident you can figure out how many degrees should be given to breakfast and how many degrees should be given to lunch. And if you can find all those three things, I feel pretty good about your chances to make the pie chart. Anybody have questions about any of that? Okay. We talked about a couple of different types of graphs today. I just kind of want to reinforce what they're for, what they do. A bar graph, the big advantage to a bar graph is that it shows raw data. You'll notice the line graphs show raw data too, but the pie charts don't. So when we're comparing things in different categories, the bar graphs and the pie charts do different jobs. Bar graphs, we can see raw data, but we can't necessarily see, well, one of these is about, half of the whole thing, which we can see in a pie chart. But a bar graph will show us the raw data, and those different categories can be arranged in any order we want. A histogram is sort of a subset of bar graphs. It's a special type of bar graph where we have continuous data and we don't put any gaps between the bars. Again, more important down the road in section 7.3, but for right now, knowing it's a special type of bar graph with some special rules is what we're after. Line graphs, great for change over time. That's their strength because we can see ups and downs really nicely. We can see increases and decreases. And then finally, pie charts, those are great for showing relative percentages. I can see at a quick glance that almost half the people in this, almost half the people in this thing chose dinner as their favorite. If we look at this picture, we can see darn near half chose dinner at a quick glance. If it were a bar graph, that might not be as obvious. And so showing those relative percentages is the strength of a pie chart.